So now I'm presenting my third homework, that is for AI. Now moving on. So basically, I'm comparing the reasoning and problem-solving ability of two LLMs that I've chosen. That is Gemini Pro 2.5 and the ChatGPT 5 free model. So these are the two LLMs that I've chosen, and the transcripts that I've made, I've attached them in the zip file. So I made basically 6 documents, two LLMs, that is Gemini Pro 2.5 and ChatGPT 5 free model, and we had three problems. First one was the rider order allocation problem. Second one was container loading optimization, and third one was the kabaddi game simulation. So these were the three problems, and for each of the three problems, I used two LLMs. So we made 6 documents that are saved in this format. Moving on. So firstly, rider order allocation problem definition. So we have two riders R1 and R2, and they must deliver the orders across connected nodes. The objectives were mainly to minimize the total fuel spent for all orders, and also to minimize the elapsed time for all orders to be delivered. So we have basically I made 5 distinct cases. Each instance altered the topology, right? So this is a summary of the prompts, how I gave them and how they changed with each prompt. So for instance R1, the key variation is basically this is the base case. So we have two riders and three orders, and this is the example. That is, original distances were maintained A to F graph. In R2, we added a third rider at C. So this basically would explore effect of extra capacity. Then I gave the LLM another instance, that is R3, which altered the edge weights. So that would be testing the numerical reasoning and robustness of the LLM model. Then R4 was given, that is added a new node G plus the extra order, another order I added. And in R5, we basically use numeric graph with 1 to 5 nodes. So, and also each instance that I gave to the LLM was written entirely in English. So I didn't use any JSON or tables as per the homework instructions. So basically the prompts were given in the format that is mentioned. Consider the following road distances between locations A to B, then given the edge weight 2, A to C given edge weight 4, for example, and C to D, let us say 2. And then also in English only I wrote there are two riders, uh, R1 is at A and R2 is at, let us say, D. So in this format I just gave the prompts. Moving on. So the behavioral analysis, ChatGPT performed well. It uses quick, greedy choices and matching methods, which can miss the best fuel saving plan. While for Gemini Pro 2.5, it tries to solve the problem by checking many possibilities, but it stops too early, so it misses better solutions when the map gets larger. Both produced valid allocations, but Gemini adhered more closely to the optimization goals. Now, the strengths of ChatGPT, it often uses quick, greedy shortcuts, which makes it fast, but it can also miss out on the best overall solution, and sometimes forgets that deliveries can be done at the same time. So the solution it followed was based on matching the riders to orders to save fuel and then balancing the workload to reduce total time. While for Gemini, it tried every option but stops too early. So as the map gets bigger, it misses the better routes. It uses a it uses a full search. It used a full search of all ways to split the three orders between the two riders, then chose the one with the smallest total distance. Now moving on to container loading problem. So basically, in brief, we have multiple containers with varying weights and destinations must be with varying weights and destinations, and they must be loaded onto the ship stacks on the left and the right side. And our goal is to provide a complete assignment of each container to a stack and the slot order bottom to top. And the show we have to show per container Euclidean distance calculations, per stack inversion counts with exact comparisons, left right weights, the balancing penalty, and the final cost that we have. If multiple placements tie, then we list them and pick the lexicographically smallest stack ID. So for this also the prompts were given completely in English, right? So for example, the containers like C1 with weight 12 and destination, let us say destination port number 1, and the position mentioned in normal format in XY coordinates like 42, 33, right? So that is the format only in English. Now, ChatGPT basically tends to rely on intuitive heuristic reasoning. It confidently tries to solve every prompt, even when some are unsolvable, and sometimes gives incorrect answers even for the solvable ones. While Gemini follows stricter algorithm logic, it was able to identify when a problem cannot be solved, but often it cannot produce the correct solutions for those that can. Its reasoning is more structured than ChatGPT's. That is what I noticed. Gemini provided more deterministic stepwise plans, while ChatGPT's approach was intuitive but less precise. And I also gave 5 different instances where different with different yard coordinates and basically the weights for them. The for each prompt, mainly what the things I changed were the yard coordinates, the weights, and also the stack capacities, and height limit also I edited for some of the prompts. So that was the differences in the 5 prompts I gave. Also, I experimented with the containers count. That is, I increased it to 6 in the fifth prompt that I gave to the LLMs. Moving on. So ChatGPT thinks more creatively and uses human-like intuition. It tries to balance different needs at once, like the order of unloading and keeping the load stable. While Gemini follows a more strict, step-by-step logical approach, and it focuses on meeting all the rules and limits of the problem. Gemini was slightly more accurate when deciding the best way to load items. Now moving on to our third problem, that is the Kabaddi game. So these are the game rules. Let me go through them in brief. So the grid, I basically give this as the prompt only, that we have a grid 5 cross 8 with 5 rows and 8 columns. Coordinates are row, comma, column with rows 0 till 4 and columns 0 to 7 indexing. Then team A territory is column 0 to 3 and team B territory columns 4 to 7. We have two players, A0, A1 from team A and B0, B1 from team B. We have gold position at these locations. The capture rule is given. There is a player who moves into a cell occupied by an opponent who is present in the mover's territory, captures that opponent would be removed. If the captured player was carrying gold, that gold would return back to its home cell. And a player picks opponent gold if they move on to that gold cell and are not already carrying gold. Win condition is that we carry opponent gold back to our territory or we capture all the opponents. And the instructions that I gave for the LLM were, you are team B, that is I'm giving this instruction to the LLM that you are team B, that is you have players B0 and B1, and provide moves for both players in exact format, right? That is in row column format for each updated move. And we have only 4 directional movement. That is, we can either move to north, south, east, or west, or we can stay, depending on the problem, how it happens. Do not propose illegal moves outside the grid or greater than one cell. And briefly justify each move. I will apply the moves and post the new board. Then you respond for the next turn. Start with first instance, Kabaddi scenario K1. And these are the initial positions. Start with team B's move. And this is basically the prompt that I gave, right? And then I edited the prompt as well for each of the different instances. So the behavioral analysis first. ChatGPT plays aggressively and improvises a lot, but it sometimes made illegal moves. It broke the rules, messed up the board, or it lost track of earlier game states. As for Gemini, it played safely and followed the rules more closely than ChatGPT 5, the free model. But it sometimes tried to twist the rules or ignored the actual win conditions, and it also made some wrong board updates. ChatGPT adjusted quickly to the opponent, while Gemini kept repeating the safe, predictable strategies. And ChatGPT was good at adjusting to different situations and coming up with clever ideas. And it aims to respect both the order items need to be removed and how evenly the weight is spread. Right. Moving on. So finally, LLMs can explain AI problems very well, but they cannot be trusted to actually solve them. They make up steps, they hallucinate, misjudge the best answer, and sometimes perform actions that aren't even allowed, especially when the task requires long, careful, and deep reasoning. So classic algorithms like beam search, A star, or simulated annealing performed much better because they follow strict rules, they check all needed options, and are not approximate and probabilistic like LLMs. And that's it about the video.